Okay, Saxon 4 math students, we're ready for lesson 81, angle measures. We've talked about angles before. We know that right angles are 90-degree angles. You can draw a perfect little square in that angle. Anything less than 90 degrees is called an acute angle, and anything larger than 90 degrees is an obtuse angle. So now we're going to practice actually measuring angles. So let's go straight to the practice. And we're going to use a tool today called a protractor, and I have some of those for you to practice with. I want to teach you how to use it first. Both angles A and B that we're going to look at here are open to the right. That's very important for you to see because that's where we're going to look at the zero on the right side. Now to line up a protractor to measure an angle, you don't put it with the protractor's edge. You look at the baseline on that protractor and you're going to kind of match it up to the angle. Put the base and the angle perfectly. See that right there? And we're going to look at the zero to the right because there are two sets of numbers, and that depends. That's because sometimes angles are open to the left and sometimes they're open to the right. And you look at the zero to the side that the angle opens up. So we're going to look at the right, 0, and follow it all the way up, and it looks like this angle measures 60 degrees. So we'll write that just like you would temperature, okay, with a little degree mark. Now let's measure B. Okay, so I have to line it up with the baseline and the angle. And it's kind of, this virtual one is kind of hard to do. Take some practice. One cool thing about this virtual one, I can slide this little measure over and match it up to my angle. And you can see that it's about 85 degrees. And again, I looked at the zero on the right because my angle is open to the right, so I follow those numbers. Okay? That's the trick. Now let's look at some angles that open to the left. That means we'll have to start looking at the zero that's on the left side of the protractor. Whoops, didn't mean to resize it. Let me get my four-sided arrow. There we go. Now I can drag it around. Again, I have to line up my base right with that angle. If I'm off lining it up, then my measurement's going to be off. It's not going to be accurate. Okay, again, angles open to the left. I find the zero on the left. I go all the way over to where my angle is. It's right here, and I'm looking at this number, 120 degrees. Okay, let's try one more. That was an obtuse angle, wasn't it? Greater than 90 degrees. Let's try this one. We have to measure, line up with the base. Okay. And again, it's open to the left, so I follow the zero on the left. And we can see that it's about in between the 40 and the 50. So that would be, what's between 40 and 50? 45. 45-degree angles are pretty cool because if you look, it splits a 90-degree angle. If I were to trace this, it's not going to let me trace it. It would split it right in half, okay, because 45 plus 45 is 90. So a 45-degree angle is half of a 90-degree angle. Okay, let's look at, it says at 9 o'clock, the hands of a clock form an angle of how many degrees? So I've got our clock here at 9 o'clock. And it's very easy to see that this is a right angle, therefore it is 90 degrees. Okay, now we'll save the facts for the very last. Let's do some mental math. Okay, now we have a new trick for mental math with subtraction. And it says we need to increase both numbers so that the second number ends in 0. So let's look at 28. Let's increase it to 30. That's increasing by 2. Let's increase 63 by 2. That would be up to 65. So now we have an easier problem. 65 minus 30. 35. Let's increase 17 to 20. That's adding 3. Let's add 3 to 45. That would be 48 minus 20, 28. Let's increase 46 all the way up to 50. That's an increase of 4. So let's add 4 to 80. So we've got 84 minus 50, 34. Noah had $10. Then he spent $5.85 on lunch. How much did he have left over? So I like to start by counting up and looking at the cents first, and I know from 85 cents up to the next dollar is a difference of 15 cents, so that would get us to $6. Then from $6 to 10 is $4, so we have $4.15 left over. How many inches is half of a foot? Well, 1 whole foot is 12, so half of that would be 6 inches. How many inches is 1/4 of a foot? Again, a whole foot is 12 inches. Divide that by 4 and you get 3 inches. That's 1/4 of a foot. Estimation: the total cost for 4 movie rentals was $15.92. Round this amount to the nearest dollar and then divide by 4 to estimate the cost per rental. Okay, let's round this to the nearest dollar. Is $15.92 closer to 15 or 16? It's closer to $16. Then we divide by 4. 16 divided by 4 equals $4. Each rental was about $4. Okay, this one is one we're still getting stuck on, folks. 5 squared means 5 times 5, okay? Not 5 plus 5. And not 2 times 5, okay? It means write the 5 down twice and multiply it. Multiply it, okay? So if 5 squared really means 5 times 5, then we've got 25. Times 2 is 50. Times 2 is 100. Times 2 is 200. Times 2 is 400. Problem solving. We've got a diagram here, students with pets. In the diagram at right, the circle represents students who have 1 or more pets at home. A letter inside the circle represents a particular student who has a pet. A letter outside the circle represents a student who does not have any pets. The letter A represents Adrian, who has a dog. The letter B represents Beth, who does not have any pets. Copy the graph on your paper. On the graph, place the letter C for Clarissa, who keeps goldfish, and D for David, who does not have pets. So C for Clarissa goes inside the circle. This is a piece of cake. And D for David goes outside the circle. Should look something like this. Okay, now we're going to go back and do our facts. And your objective is to try to beat me, okay? Let's see if you are faster than my finicky pen pad here. And there you have it. And we are finished.